So this is the Chem 1 lecture over classification of matter. So matter is anything that has mass and takes up space. So pretty much most everything is matter. It's going to have some kind of mass to it, weight, and it's going to take up some space, some volume. There are some things that aren't matter. Some examples would be energy, light, heat. All of those things are not matter because they don't have mass or take up space. And we're going to go through today different ways to classify matter. So one way to classify matter would be in elements, and that's kind of the most basic part. So elements is just made up of one type of thing, one particle, or one type of atom, and those atoms are found on the periodic table of elements, so you'll just see the name of them, and it's just like they are on the periodic table: sodium, sulfur, oxygen, hydrogen, helium, any of that stuff. So it's just made up of one type of thing. And below, we've got some pictures of what these guys look at the molecular level. So that means if we were looking and we're actually able to see the tiny little particles that make up this matter, you can see that each of these, element A and element B, are made up of the same type of little dots. And those would be individual elements. I can see A is made up of 1, 2, 3, 4, 5, 6 teeny tiny white circles. So those would be our elements. Now B is a little bit different because I can see that even though we do have colored in black dots, they are paired up. And so that is actually because element B is something called a diatomic, prefix di meaning two, atomic meaning atoms. So a diatomic element doesn't exist as a single atom in nature, but always as a pair of the same element bonded together. There's 7 elements in the periodic table that do that. We'll spend more time later in the year talking about them, but you do have them listed on your notes, and you notice when the formulas are given, each one has a little subscript 2 after them, because in nature, hydrogen doesn't exist as H, right? It always is 2 H's bonded together, so it's called H2. So another way to classify our matter would be with compounds. And compounds are actually a combination of different elements that are chemically bonded together. So they're actually stuck together. Compounds are oftentimes written by their chemical formula, so something like NaCl. You can see that I've got 2 different elements. I got Na and I got Cl, and they're stuck together. In this case, when you see the formula, it's pretty easy to see that there's different elements chemically bonded together, but sometimes you'll see their chemical name written. So instead of seeing NaCl, you might see the words sodium chloride. And a good rule of thumb is that if a substance ends in "ide," "ite," or "ate," recognize that as a compound at this point in time. Finally, sometimes compounds have common names, like salt. There's a whole lot of common names. The only ones you're going to be responsible for in here are salt, sugar, ammonia, alcohol, and water. So if you see those, you'll be able to recognize that that is actually a compound, even though we can't see what individual elements make those things up. Properties of a compound will be different than the properties of the individual elements that make it up. So for example, water, we know the properties of water: it's clear, we know the density, we know that it's a liquid at room temperature. Those properties are very different than hydrogen and oxygen, which are the 2 elements that make it up. Hydrogen by itself and oxygen are both clear, flammable gases. So those properties of those 2 individual elements do change when they become bonded together. And we've got a picture of what a molecule of this is actually water, but of what a compound would look like. And I can see that I have 2 different elements bonded together. I've got that colored in solid element, whatever that one is. In this case, that's oxygen. And then 2 little hollow dudes up there, which would be the hydrogens in that case. But they're actually touching each other, so I know that they're chemically bonded together. And last, elements and compounds are both considered to be pure substances. We got another vocabulary term here, so you probably want to highlight that guy, pure substance. And they're both considered pure because they have a set or constant composition. Whether it's just a sample of oxygen gas or a compound, something like water, it is a set thing. It's always the same. No matter where you go, water is H2O. It doesn't matter where it comes from. If it's just water, it's always going to be 2 H's for every 1 O. It's a set composition. So below we've got a table here, and we have to decide whether that sample is going to be an element or a compound. So, and I'm going to abbreviate them: C for compound and E for element. Let's look. First, I've got salt, NaCl. I can see that I have 2 different things bonded together. I've got Na and Cl. So even if you didn't know what those were, I can see that I have 2 different things combined, so it's a compound. Silver, although, is just one thing. It's just Ag, so it's an element. Same thing with fluorine. Fluorine, if you look at what it is, it's F2. So it's only made up of F F atoms, although it is a diatomic since I've got two bonded together, but it's still an element. Next, let's see silver fluoride, two different elements, Ag and F bonded together, that's a compound. And last, magnesium sulfate. I've got three different elements here. I've got Mg, which is magnesium, S for sulfur, and O for oxygen. I have four of them, so that's a compound. So next, we're going to talk about mixtures. And mixtures contain different things that are physically mixed together. So this is different when we talked about compounds, because those are different elements bonded together, but this is physically mixed together. We get a compound. And they can be classified in two different ways. So they can be considered homogeneous or heterogeneous, and you may have seen those prefixes before. Substance that is considered homogeneous, it means that it all looks like one substance once it's mixed together. Another name for homogeneous or homogeneous mixture is called a solution, and you'll see that again. And heterogeneous mixtures means that they are unevenly mixed, okay? So when you do have that mixture, you can see that there's multiple substances mixed together, something like Rocky Road ice cream. You can see the different chunks in there. So we've got two different examples here, mixture D and mixture E, of different types of mixtures. So let's see, mixture D, it says a mixture of compounds. So if we look at mixture D, I got two distinct types of compounds here. I've got this little Mickey Mouse dude here, and I've got these little double dots. So here, I've got two different things going on. And same thing, E. It's a mixture of elements, because if I look at the two things here, I've got the big single dot and then the smaller double dots. Those guys are two different types. Each of those would be classified as an element. So now we've got another table here that we need to categorize the following samples as homogeneous or heterogeneous. So let's go through and figure out which one would be evenly mixed, as in homogeneous, or unevenly mixed as heterogeneous. So first we have nuts and bolts. Those would be two different things. We would assume that those are unevenly mixed, so it would be heterogeneous. I'm going to abbreviate that HE. Next, I've got bronze. Now, this one you may have to look up, but bronze is a mixture of two different metals. Think about what bronze looks like. If you were to look at bronze, think about the medals at the Olympics. It looks like only one thing, right? I can't see individual little pockets of copper and of tin. It's actually homogeneous, and in fact, it is actually considered to be an alloy. An alloy is actually a mixture of metals, so they're mixed together when they're molten or liquid. Cheerios and milk, that would be heterogeneous. I've got two distinct things. I can find the Cheerios, I can find the milk. And the last one, Kool-Aid. So let's think about it. If we've got Kool-Aid made up, a big old pitcher of Kool-Aid, I can't see any identifiable parts. Like, I know there's water in there, and I know there's sugar in there, and I know there's Kool-Aid powder in there, but I can't see those individual parts. That would be homogeneous. That would in fact be a solution, because I've got a Kool-Aid mixed with water situation. So that would be homogeneous. That's actually a solution here. So another way to classify matter is into the states or the phases, and I know this is something that you guys have learned about in previous science classes. There are four states of matter: solid, liquid, gas, and plasma, and here we're going to focus on the three kind of basic ones, solid, liquid, and gas. And we've got a chart that kind of describes each of them. So let's see the shape of them. For example, solids do have a definite shape. They don't take the shape of their container. Think about it, your pencil is going to stay the shape of the pencil. Same thing with the volume. It does have a definite volume. Your pencil is not going to expand to fill the container it's in. It's not going to expand to fill the room. And those particles do have very little motion. Now, obviously, there's all motion in particles, but these guys are just kind of vibrating in place, and these particles are very close together. It's usually the most dense state of matter. Next, we have a liquid, and think about liquid in your water bottle. It takes the shape of your water bottle. So liquids don't have a defined shape. They do have a definite volume, though. Liquids don't expand to fill their container. If your water bottle is half full of water, it's going to stay half full. That water is not going to expand or go anywhere. So they kind of have medium motion here and medium distance apart. They're kind of the in-betweeny. And then the last state of matter we're really going to focus on are gases. And gases do expand to fill their container. I always think about when you light a scented candle or you spray some room spray in the corner of a room, you wait long enough and it's going to fill up the entire room. It will expand to fill the container, so it's got an indefinite shape and volume. It's going to expand to fill it. And these guys have lots and lots of motion. That's why they can always mix themselves. Lots of bouncing around there. And those particles are very far apart. Gases are actually mostly empty space with a few little particles flying around. So knowing the states of matter help us determine if a mixture at the atomic level is homogeneous or heterogeneous. For example, gases are colorless, and if you mixed multiple gases together, it would be homogeneous. You wouldn't be able to see anything. And we know with so much motion in those gas particles that they're going to mix themselves. So a good example of a homogeneous mixture of gases is air. So the air we breathe contains a lot of different gases in it. Oxygen, carbon dioxide, nitrogen, lots of different gases. We can't see the individual parts. They are evenly mixed. So next, let's see, for each substance below, identify the state of matter and whether it's homogeneous or heterogeneous. So the first one's worked out for us. If you look at these particles, I can see that they're nicely, neatly stacked up here. And although they're not touching, so I know they're not bonded, it is a solid. They are not taking the shape of the container, and they're not expanding in any way. It is a homogeneous mixture because these, even though there's not very many particles there's what, 9? They are as evenly spaced as we can space 9 particles. And I like how it does tell us that it's an alloy, which is a mixture of metals. And actually, I could tell you that it's a mixture of individual elements, since those 2 different types of dots aren't touching. They're not compounds. So if we look at our next one, I can see that we have kind of 2 things going on here. I've got this box of elements down here, and then I've got these other guys floating around up here. So I know there's 2 states of matter here. The blocky guy is going to be a solid. I'm just going to write an S here. And then the little dots floating around, I can see that they're taking the shape of the container, and they're also expanding to fill the container. They're floating around. So I know that that is actually a solid and a gas together. And let's see, that mixture, is it evenly or unevenly mixed? Well, I can see that I have kind of just 2 distinct areas. I got that solid down there on the bottom, which I'd assume we'd actually be able to see from the naked eye if we weren't actually looking at these little molecules, but in real life. And I know we wouldn't be able to see the gas floating around, so I would say that that is a heterogeneous mixture. These guys are unevenly mixed. I'm going to write HE there. Okay, and the next one, I can see that I got everything floating around here, so it's a gas. And even though I don't have a lot of particles here, they do look relatively evenly mixed. So I'm going to write homogeneous here. Plus, if you have a mixture of gases, it is always, well, 99% of the time it's homogeneous. And then the last one here, looks like I got 2 different things going on here. Looks like it's 2 different compounds. And they are definitely not a gas because they're not floating around, but they don't have a defined shape. They're kind of taking the shape at the bottom of the box here. So I'm going to assume that this is a liquid. And I can just see that I have 2 distinct layers here. I've got one type of, well, those are compounds on the bottom, and another type of compound on the top. So I'm going to say that it's a heterogeneous mixture. It's actually 2 layered liquids on top of each other. So on this third page, I can see that we've got a flowchart that kind of summarizes everything in the previous pages. So I can see that I've got pure substances here, which means they have constant composition. So they do have chemical formulas, and that's made up of elements and compounds. Elements are made up of only one type of atom found on the periodic table, while compounds are 2 or more elements that are chemically combined in a set proportion. They're always going to be the same thing. You can't physically separate them. You can only separate them with chemical means, which we'll talk about later. And the properties of a compound are different than the properties of individual elements. We got some examples down here and some molecular pictures. So then over here on the other side of our flowchart, we've got mixtures. So remember, mixtures are things that are physically combined. There's no set proportion, so it's all a little bit different. They can be physically separated since they're not chemically combined. And the different components do keep their original properties. So if you have Cheerios and milk, your Cheerios are still Cheerios and your milk are still milk. They're just combined together. And that's not a set proportion. Maybe I like more milk in my cereal and you like more Cheerios. Still both cereal, both Cheerios and milk in different proportions. So homogeneous means that those parts are evenly distributed. It looks like one thing, so we have that other vocabulary term solutions in here. Heterogeneous means they're not evenly distributed. You can actually see separate components in it. And so we've got some examples and some pictures at our molecular level here. The last we have is the practice associated with this. And you're going to do this on your own. You got a table here. Be mindful that you will not fill in every column because it depends. For example, column 4, you're only going to fill that out if you have a pure substance. Columns 5 and 6, you'd only fill out if it were a mixture. This last portion gives you an option to draw. So it says draw the atomic representation of the following at the atomic level. So it's actually drawing, hey, we want you to draw these dots. What do these look like? Is it a single dot? Is it two different types of dots put together? Is it a mixture of those? This is where you get to be a little bit flexible in what you guys draw.